Okay. Okay, then now let us start a presentation on law and AI. And also this is I'm still a bit of a beginner to this, so feel free to like jump in anytime or like type in the chat questions or anything and basically just interrupt me at any point. Okay, and first acknowledgements. Firstly, thanks to Ao from the Alliance server for introducing to me to this topic because I never knew like law was like such a difficult thing to solve by computers until I talked with him. So yeah. Anyway, first of all, an agenda for this presentation. So firstly, I want to introduce like the basic idea on like why law is hard. And then secondly, I want to kind of like talk about some logic frameworks or like programming frameworks that people have made to kind of like tackle this problem. And I want to show that it's very inefficient to do this. So next, I want to talk about how people approach speeding this up. And finally, so I want to talk about data issues and the current large language model solutions to like law with AI. Okay, so firstly, for like why that is hard, with the help of like the Hugging Face community members thing, we narrowed it down to like mainly like 3 fundamental issues on like why that is hard. Now, first of all, like in the structure of the court, there's like a judge, and there's like the prosecution, and there's like lawyers. And currently, the idea is, can we replace the judges with like AI or computers? And yeah, kind of like, I think it's like a pretty interesting problem that we all thought of at least once. Like, let's say in a criminal case, right? You have the evidence and you have like arguments for why the defendant is guilty. And then you have the arguments for why the defendant is innocent. And then basically the idea is, can't we just like plug this into a computer and like just compute an outcome? Also kind of like more like detail, can't we just make like a series of if statements or like if you're a bit more familiar with AI, like a decision tree on like, let's say the guy has like a knife and like he kind of like attacked a person, then can't we just kind of like go through this has a knife, attack the person chain and like say that he's guilty or something? And kind of like this is to a certain extent true, like you can do it, but you kind of run into this kind of bit of a logical issue called the 3D bird issue, which is something that kind of law is very much similar to. So first of all, 3D here.
Wow.
Oh, yeah, kind of like 3D here is I'm not sure if this is a Disney character because I don't watch too much, but basically she is a bird, and like you have like we start off with the rule that birds can fly, but and 3D is a bird, so she can fly, right? But then kind of like there's this problem that 3D is a penguin. But so penguins can't fly. So kind of like it kind of contradicts this original claim that birds can fly, kind of. Like we need to take into account that 3D is a penguin. And kind of like, I think this is a bit too abstract. So I wanted to kind of like go into a bit more of a real life example. Oh yeah, any questions so far? Okay, no questions so Okay, no questions so far. Oh, thank you. So yeah, kind of like basically what I wanted to say is that in like law cases or like books or anything, I think you'll notice that sometimes there's like a twist. Like a new argument can come out of nowhere, and kind of like we have this kind of carefully laid out series of arguments, but like a new argument can come out of nowhere to kind of completely invalidate all our reasoning. And this is called non-monotonic logic. And basically, what this means is that you can't have like you can't have facts in a way. Yeah. So like, yeah, every time you kind of like lay out the chain, and like every time there's a new argument, you might need to recompute the entire argument from scratch. And a real life example of this that I found was a case called Map v. Ohio. And this is like a United States case, a Supreme Court case. And it's historically, it's a pretty interesting case because basically what it did was it made like police searches without a warrant illegal. Or to be more specific, you can't kind of like bring evidence that you acquired without a warrant into like court cases. And this is called the exclusion rule. Anyway, yeah, kind of like this is an interesting case, but let me first kind of like talk about the background for it. So first of all, there was like the Fourth Amendment, which is like a constitution for the US. And basically what it says is that every person has like, is like secure against like kind of like unwarranted searches and stuff, unless there's like a warrant. Basically that's what it's saying. And the full text is here. But kind of like interestingly, in a case before this, in a case before Map v. Ohio, there was a case called Wolf v. Colorado. And basically what it said was that on the state level, let's say like Pennsylvania or New York and stuff, on the state level, even if the police kind of like acquire evidence through like without a warrant, you can kind of like use that in court. And the justification the judges used for this is, there were many, but one of them was that a lot of the states, they were kind of very skeptical of this exclusion rule stuff. And like half of them at the time were against the exclusion rule. And like they had like legislation and like laws that they made that were kind of like fighting against this. So this was the case in 1949. In 1961, in the Map v. Ohio case, they overruled this previous ruling because currently 2/3 of the states support like the excluding the evidence from unwarranted searches stuff. So basically what happened here is a bit like Tweety Bird, because with like the new argument introduced, it kind of like invalidates the previous conclusion of Wolf v. Colorado. And kind of like the main interesting thing, in my opinion, about this is that kind of like between cases, the laws change, or like the laws and like the premise of each case changes. So like each judgment can be like entirely correct, but like the premise can be different, which makes them contradict each other. And also another thing that I wanted to mention here was, I didn't mention here explicitly, but these two are like, I think, Supreme Court cases. And like the judges don't unanimously agree on the same conclusion. Like even judges who are like trained to kind of like come to like a conclusion to resolve like arguments of the prosecution and lawyers objectively, they come to like different conclusions. And I don't think there's like many cases where they unanimously agree on the same decision. And I think that's kind of very interesting in the logic point of view. And yeah, here I wanted to point out the first fundamental issue with Ra that I think you guys might have kind of gathered already. Kind of like law is maybe purposely made to be like very ambiguous and open to interpretation. So like if you try to like code Ra into programs where like, let's say for the Fourth Amendment, when we try to kind of like change it into code, we need to kind of like add our own interpretation to it. And I don't think kind of like from the starting point, we will necessarily conclude like Wolf v. Colorado where like on the state level, like you don't have to do warrants to exclude, or you don't have to do warrants and just get evidence and stuff like that. Kind of like, that's like all like, basically kind of on every court case and every like law change in the country, this kind of like code for the law needs to constantly be updated. Oh yeah.
Little ones? Yeah.
Oh, is that a question?
You want water? I mean, are you the matter?
Thank you. Yeah, just remember to turn your mic off when you join. Thanks.
Oh yeah, but feel free to like ask questions or interrupt me anytime, because happy for like dialogue and stuff. But yeah, basically kind of like while like the idea of code of law like currently at this very moment is very possible, you will have no idea what the new code of law is after like every new court case and every new like law made or by Congress and stuff. Now kind of like one thing I want to mention that the Hugging Face community member Singh mentioned was there is also actually like an open initiative to like code the current interpretation of the law into like code. So it's called Katara, and I haven't looked too much into it, but I don't think it's adopted at scale at the current moment, but I think it's like very interesting thing to look at if you guys are curious. And there's a GitHub account too. Okay, so we kind of like talked a bit about like the general idea on like why law is hard and stuff, but how do we even kind of like approach like programming something like these kind of contradictions and stuff like that? And kind of like the first paper that is pretty it's kind of pretty famous paper on like how to resolve arguments, like this kind of like contradiction, this kind of like non-monotonic logic, is a paper by a guy, a pretty, I think, famous guy called Min Dang, called On the Acceptability of Argument and its Fundamental Law in like non-monotonic reasoning, logic programming, and person games. So now, let's say you are like a judge for a debate, and you have in front of you like two contestants and like three arguments. And this is like the argument that was present in that paper. So basically I guess this isn't a debate, this is like a national dialogue, but I here says I cannot negotiate with A because they don't recognize I. And A says I doesn't recognize A either. So basically they are both not recognizing each other. And now I says, but A is a terrorist organization. So the question that the paper asked was like, who won this argument? And kind of like, I think this kind of ignores like many of like the fundamental claims of like each other, but let's just say like, given these three arguments, who won the argument? And when we kind of like formalize it, so let's say this first argument is I won, and this next argument is A1, and this final argument is I2. Since these I1 and A1 kind of like, they kind of attack each other, right? They can't coexist at the, they kind of like arguing with each other in a way. Like, I1 is saying like, I cannot negotiate with A because A doesn't recognize them. Well, A is saying that I doesn't recognize A either. So they're kind of attacking each other. So neither side won at this point. And what this paper is saying is that this new claim saying like, but A is a terrorist organization, this kind of attacks A1 and basically kind of like invalidates this argument. So then what this paper is saying is that the side I won. And the idea here is like the argument, the guy who does the last argument wins, basically. Now, kind of like, that was a very simple example, but I wanted to kind of like, I wanted to add my bit of interpretation to this. So, in this world, the question is, when is an argument acceptable? Or like, when is it like, when can we say our main argument is true? And the idea is, you have your main argument, and let's say your main argument is this castle, right? And you have all these counter arguments, or like, these people are attacking. And you can say your main argument is acceptable if you can defend against every single counter argument. And what this means is that you can attack every single counter argument. So yeah, kind of like in this case, for kind of I1 to be defended, I2 needs to attack it. So basically for every argument, so if I1 is a castle, a main argument, we will always need to have like for every A that attacks I1, like a new argument or like the same argument that attacks all those other counter arguments. Does this so far make sense? Okay.
Hello.
Hello.
Yes, so the last argument that it says that I2 defends I1.
Yeah.
But he just claimed that he is a terrorist. So, does it make sense?
So yeah, kind of like, I think that's a very good point. Like the contents of you're saying the contents of I2's argument doesn't like make sense in terms of like resolving the argument, right?
Yeah, it's not defense, it's a kind of attack to A1.
Yeah, that's absolutely correct. But what this kind of framework is saying is that if A1 has an objection, they can attack I2 again. And like when both sides like completely exhausted all the arguments, the guy who did like the last argument that kind of like the other side can't object against, they win basically. So like if like A1's the side A says, well, like I is a terrorist organization too, then it'll be another stalemate basically. Yeah, does that make sense? Kind of like that's like the main kind of like thing I gathered from reading this paper. Okay, then yeah, so kind of like so kind of like this is kind of like one assumption that I think is important here is that this assume that there's like no time constraint and like both sides have like all the time in the world to argue with each other until they stop being able to kind of like come up with new arguments to defend against. And I think that's kind of like generally true for court cases. Like there's like that kind of assumption that there's like no more arguments that you can come up with, basically. So now kind of like the next idea is, okay, so now we have like a bunch of these arguments attacking each other, like let's say 5 billion of them. Can we kind of like somehow get like the main arguments from these kind of like all these arguments attacking each other? And yeah, the question is yes. So let's look at the example of this, and let's say like each of these arrows are saying that they are attacking this argument. So here A5 is attacking A6, A3, A7. Now for this A1 and A2, they are not attacking any of the arguments. So we can say that this is like, regardless of, yeah, go ahead. Okay, regardless of like which side, A1 and A2 is like always accepted, or like is always true. And then kind of like the other one side of the argument is, so let's look at the arguments that are not attacking each other. Then we have A1, A2, A5, A4. And another important thing that I won't go into much depth to because it's a bit complicated, but basically another thing to mention is that all these arguments are defended against like outside attacks. Like let's say for A4, when A7 attacks it, A5 attacks back A7. And A5 is like, when A5 is attacked, A5 defends itself. So basically this is like a small cluster of arguments that defend itself. And also another, so this is like one side, A1, A2, A5, A4. Another side is A1, A2, A3, A6, A7. And so kind of like these are called complete extensions. It's kind of like a way to cluster arguments. And they are like and yeah, they are like ways to kind of like calculate this. And basically kind of like the idea for law is that when you kind of do this with like a list of arguments, you will be left with the side for the prosecution, the side for the defendants, and also another cluster for like the true facts. But I think you might notice a new problem here. So we got the clusters of the main arguments. So like a cluster for like the common facts, a cluster for like the lawyer side, and a cluster for like the prosecution side. But then how do we come up with who's guilty? Or like whether the defendant is guilty or not? And to do this, basically we still need a judge to like choose which side won. so kind of like overall, even in the best case scenario where we can objectively find all the argument clusters, we still need a judge to resolve like who actually won the argument. Or another way to put it is we need a judge to come up with arguments to kind of like destroy one side to kind of like resolve all the cases and say like, oh, okay, so this is the final verdict. So yeah, even in the best case scenario, we still need judges, unfortunately. So that's the second fundamental reason for why that is hard. Yeah, that does make sense. Okay. Now, kind of like the next thing that I was interested in was like, okay, so we might still need judges, but finding these main arguments will help a lot. So like, what's the computational complexity of like finding these main arguments? And the answer to that comes from this kind of paper called an answer set programming approach to argumentative reasoning in the Aspic Plus framework. And yeah, basically the idea here is we can map all these arguments to like set of rules where like basically the conclusion of the argument is the head and the body is like kind of like the justification for each of the arguments, if that makes sense. So yeah, basically one way of saying it is all the arguments can be mapped to like the reasoning for the argument and the conclusion. And why we do this is because this kind of like thing called nth set programming, you can kind of use it for like stuff like the problem of like coloring each vertex so that the next vertex has a different color, or like finding like finding like a path in a graph where like no two lines intersect each other. And yeah, these problems are like, if you're like a computer science student, I think you might recognize these problems. And these problems are called NP complete problems. And basically, these are like a set of problems where you can kind of like, when you look at it, you know that it's correct, but the best way to come up with these kind of solutions is like brute force and checking. So basically, it's something called like exponential time algorithms. Yeah, basically it's kind of exponential time algorithms, and it's very slow currently. And yeah, this is like the third fundamental issue that I personally think is a fundamental issue with this, is that finding these clusters is NP complete. So basically every new argument can kind of like completely destroy all the previous argument clusters, and we need to like recompute from scratch every time. Yeah. Yeah, so the next thing is, can we speed this up? And the question is kind of yes. And the first kind of like AI in law, which was called Hypo in like 1987, kind of did this. And basically how it works is you have the current case, and then you convert it to like a representation. And then you query like all the past cases and like the rulings for like each of those cases, and basically compare it to the current case. And then the idea is, well, since in this past case, in this situation, the judge ruled that this is like bad, then this case must be bad. And yeah, kind of like there are obviously some problems with it. Like here, the representation for the case doesn't have to be kind of like may not be always be correct. And also it also assumes like the past cases are like always true, which like in the case of like map B Ohio, that's like wrong. And kind of like in this case it mainly worked because they just worked on trade secrets, which is like it's like a very non-volatile field of law. So basically the whole idea here is they completely removed the non-monotonic part from law, basically. So the next kind of like slight extension to this is kind of like, well, yeah, that's great, but can we add kind of some tiny bits of arguments without making it like NP complete? So like giving it some like arguing ability. And the paper I found that kind of like most did this kind of like in the most faithful way I can think of is a paper called Induction of Defeasible Logic Theories in the Legal Domain. And I kind of like found it a bit funny the first time I read it, but basically you have the evidence And then you basically choose the best arguments, or like greedily choose the best arguments to come up with the conclusion with the minimum amount of arguments. And yeah, kind of like, I think guys are wondering a bit like why does that work? And I also wondered this a bit too. And basically, it doesn't necessarily guarantee that there is no contradiction or like there's no counter argument that dismantles our entire claim. Overall, it's an approximation. And I think that's interesting because there's like a trade-off between how true our conclusion is and also like the performance. Like, because we can't do like the NP, like exponential time stuff of like all arguments all day because that would be too expensive. So we need to have this trade-off. And I think human judges kind of do this too. They kind of approximate to like the main arguments of the case. And then also from previous like court cases, they get precedences, which are like the main summaries of each like case. And then they just kind of like approximate the ruling, basically. Yeah, so that's all for like the argument stuff. But next, I wanted to talk a bit about the issues with the data. Like, since this is like an AI server, I think there's a bit more. This might be a bit more interesting. Yeah. So first of all, this might be just a United States issue, but basically all the court cases in like that the US has ever done after like 2000, I think, is online. But the caveat here is like to view each page, like to view one page, you need to pay like 10 cents per page. And for audio files, you need to pay like $2.4. So like to view like one full court case with like a bunch of pages, I think you need at least like $5. That's like, I think you have at least like 50 pages across documents. And there is like a non-profit company whose like one goal is to resolve this issue. In that kind of like they have like the users install a plugin when they kind of go to this Pacer website, which is kind of like this is from the US government. And basically every time the people download a PDF or like read documents, it gets uploaded to this free court listener website. But I must say there's a bit of issue, and I think this is like in the case of the MAPI Ohio, which arguably is a very important case. But the main document, the main part of the docket, which includes like all the court like arguments between the two sides, is like nobody actually bought that on Pacer because it's like too many pages and it'll be at least like $3. So I think I'll need to check this extensively, but at least from like looking at 10 cases or so, all the main documents, all the main argument parts are behind a paywall. And the main parts that you can see is the opinion of, or like the judge's reasoning for reaching that kind of like, that judgment on like which side won, basically. Yeah, is there any questions so far? Okay, philosopher. Yeah, I think it's possible because let me just like train on like a philosophy dataset and just this skill. It's critical philosophy. Don't simply determine guilt. Restriction of the yeah, Singh definitely knows his stuff, and like he helped me a bunch in like understanding the core issues with like law and stuff. So I recommend people check his message out. But yeah, back to the data issue. So I forgot how to go from current slide. Okay, I'll just stick to here. So basically, yeah, kind of like the main document, the main arguments are behind the paywall. And currently, the largest open source law dataset is something called the PyLab by Stanford University. And basically, it's like a 256 gigabyte open source legal dataset where like basically they take from like 35 kind of like 35 data sources. And the main interesting part of this, I thought, was that the court listener dataset that I mentioned here, they only have 2 data sources from there, but it accounts for like 100 gigabytes of the 255 gigabytes. So essentially, at least in I argue that since the main documents are missing here, it's also missing from this kind of like this PyLab dataset. In that there's kind of like there's an abundance of data on the final judgment of like the judge, but there's like a severe lack of like the arguments between the lawyers and the prosecution side. And yeah, this is what I mentioned here. And another point I want to mention is I think I mentioned above that kind of like for each judgment, the premise is different. In that like the laws and like the previous cases that kind of like led up to that decision, it's different for each case. So like for like a complete, this is might be a pre-processing issue, but for like a complete data set, you will need to have like the current case and a current law and the current kind of like previous cases that led up to a certain decision, or led up to this court case, because otherwise it's very possible that if we come to a judgment currently in the current day, it will be totally false or like totally like wrong because of different laws in the past, basically. Yeah, and kind of like one low-hanging fruit that I was a bit interested in was basically the court listener site. I did mention there's a bit of a lack in the arguments department, but the court listener sites has a oral transcription of oral arguments. Actually, there's no transcription. They have oral arguments. And what this is it's basically the judge arguing with the prosecution lawyers on the main points of the court case. And I listened to Isamu, and I honestly think like just kind of like putting this in a Whisper model and getting the text and adding it to the dataset might be like very useful for like improving abilities of, I don't know, AI on arguments maybe. Now, we mentioned the data issue. So yeah, the next, I think, important question is like, what do you like the current AI what are the current AI researchers doing in terms of like all this? Like, how are they attacking the problem of law with like AI, or to be more specific, for like large language models with law? And one interesting thing I found was that the main country that is pushing for integration of like AI and stuff into law is China. In that, yeah. Yeah, basically China is like moving towards something called automating justice. And well, this is basically what I gathered from the abstract of this paper called Smart Courts, a New Pathway for Justice in China. And basically what it seems like is you basically just upload the facts of the dataset or like the case. And basically the justice just automatically decides you're guilty, you're not guilty, something like that. And it kind of like saves a lot of cost. And I guess, but of course there are like ethical arguments to it, but I just thought it was interesting. And also kind of like when you look at all the legal AIs coming out, these are like all the legal AIs mentioned in like a survey paper called like sorry, I should have put it in here, but like it was like legal survey of like large language models in AI, and these are like all the large language models mentioned. All these are like Chinese research organizations. In that there's not a, I couldn't find, there are like a tiny few amounts of like US like 1 million parameter models and stuff, but like for like big like low models, most of them are like all Chinese. And the general approaches seem to be pretty simplistic, in that this is like a diagram of like the Ryu-Lama approach. But in summary, basically the idea is to pre-train on the dataset, which means to kind of like, you basically put the LLM onto the general dataset and just make it try to predict the next token. And secondly, you make something called the instruct dataset, which is basically you have the question and you put in the question and you want the LLM to make the correct answer. And this is how you make it like a chat format. But one thing I would say is that this is kind of like the typical combo you use for like domain adaptation into like any domain. And it's not specific to law. So kind of like the most interesting AI approach that I found was something by Carp AI, which, if you guys don't know, is like a big open source research organization, which is kind of like interested in reinforcement learning with large language models. And basically what they're doing is they start off with the PyLab over here, and then they convert like each of these each document into a time series of state, action, and reward. And for how they do this is like, I think they just plug it into like GPT-4 or something. And basically what you get is the current state in text form, the action in text form, and the reward as a number. And what this reward is it's like the how legally plausible the action is given the state. And so basically it's like a judge, in that basically this model outputs how much the judge will like the current action given the state, basically. And then what they are mentioning here with the reinforcement learning with AI legal feedback, now that we have the judge, we can, given a state, or like given like the current legal state, the LLM can find like the next action to maximize this reward given this judge LLM. So basically, they kind of have two approaches of first having a judge and then using the judge to train the lawyers and the prosecutors. Yeah, so I found that interesting, but yeah, it's not without issues, in my opinion. Currently, like, yeah, basically, it's not using non-monotonic logic frameworks, so basically, it's kind of relying on the LLM itself to do all the logic for us, which I don't know. I guess it's an open problem how good that will be. But usually LLMs suffer with logic. And also, yeah, I think it has the same issue as the data, in that there's very few main documents, and you don't know like the current law or the preceding like precedences the AI has no idea like what the current law is in like making these like rewards basically. And yeah, for conclusion, yeah, the four main challenges I think for law in AI is basically the data issues and also the computational complexity and lack of considerations for like that's changing with time. Like I think that's a major issue in my opinion. And also the lack of connection to logic frameworks and large language models. Anyway, yeah, that's the end of my presentation. Thanks for listening. Yeah. Is there any questions? Thank you so much. Yeah. Yeah, feel free to group. Oh yeah.
Yeah, maybe one question. So like for a simple example, if you think of like don't kill, right? That's something we could probably broadly agree is bad, right? So if you hard code that into an AI, let's say judge, don't kill. It seems okay on its face. But then what about self-defense, right? What about if you kill something like a bacteria, right? I don't know, you're eating and bacteria will die, right? Are you responsible for that? Does it count as killing? So then would that be like, one of those cases where it sort of falls apart?
Exactly. Yeah, kind of like that's a very great example. And I think that's like the first example that Avo pointed out to me. So yeah, you have the don't, like killing is bad, like you can't kill in that. And also you have the statement self-defense, like if it's self-defense, it's not guilty. But those two are contradicting statements that you need to, that like a judge needs to resolve, basically. Yeah, but yeah, thanks for the question. Yeah, kind of like that's like the main issue with that. And honestly, yeah, kind of like I'm very curious if it's even possible to resolve these issues, because yeah, currently I think you will always need a judge and you always need negotiation in order to law to work.
Like you mean like a human judge?
Yeah, like let's say you boil down to the main arguments of both sides, and like both sides don't attack each other. How will you resolve that, basically? Like, I think the moment you try to resolve it, you're kind of like bringing your own biases into that case. Yeah. Kind of like this was something I talked with Singh about, and I think it's like one of the fundamental issues with law, I think.
Yeah, exactly. Because you would want a system. Well, maybe you would want a system that's as unbiased as possible, but at the same time, like even as humans, we still haven't agreed, for example, on what where's exactly the line between being alive and being dead, right?
Oh,
then
yeah.
for an AI, maybe that could be problematic, right? Like, ideally you would want like a binary, right? Like, okay, this is dead, this is alive. But then, even as humans, we're still having these discussions, debates about, what counts as life or as like a valid life worth protecting, and then protecting how much. So we already enter into these conversations super biased, I feel, but maybe not necessarily in a bad way, but biased because we're biased towards certain things like preserving life, right? Appreciating life, something like that.
Yeah, and also like one thing that I wanted to kind of like highlight in the MAP-P Ohio case is like like those kind of like values change over time with like each, like all those arguments, they kind of like that we want to be fact, they kind of like change with time based on like human preferences and stuff. And also that, yeah, kind of like what is alive, or like just encoding that information into like logic kind of brings in our own biases to the case too. So like, yeah, it's very hard to like objectively project like the into like human matters into like computer logic stuff.
Yeah. And then even, I think you made a really great point, like changing values over time. So for example, let's say there is a democracy, right? And then 99% of people vote like all killing, just as an extreme example, all killing is okay, right? But then, okay, it's a democracy, so okay, democracies are good. But then if the democracy votes a certain way, okay, then how do we tackle that situation, right? Because now we have like these conflicting ideas, and then it also goes back to what you said, like in our history, many cultures, many societies have held majority views that now we see as like, we don't want that, right? So then how do we maybe anticipate those, right, for the current world, we could say?
Yeah, that's a great point, but also yeah, I think like fundamentally we don't want the AI to resolve those issues. We want humans to resolve those issues.
Oh yeah.
Yeah, but kind of like this was made out of interest for like what AI and stuff was, but what AI for like legislation and stuff was, but yeah, kind of like so far I think I'm left with like more questions than answers on like how to resolve this in a way. Yeah, kind of like I guess the low-hanging fruit is if we can make the computational complexity, like if we can find the best way to approximate the argument stuff into like a non-NP complete form and like combine it with AI, I think it'll be interesting. But overall, fundamentally, at least for judges, I don't think we can get rid of judges. Yeah. Yeah, but overall, yeah, each company, yeah, exactly. Yeah, and also kind of like, also, I was talking with a friend about this, but the way like US does like the precedence-based system for like law, it's not necessarily the same for like other countries. Like other countries try to kind of like come up with like their own conclusions for each case. So like that is a huge difference too. But yeah, how to convince programmers not to concern themselves with legal research. A great point. Great point. How insight into court case management systems. You mean like representations for like each case and stuff, right? I'm not.
Yeah, from what I understand, the case management systems or whatever kind of help schedule court cases based off of like how severe they are or stuff like that. Like it's minor infractions versus big stuff. And it sounds like a nice data set, or the start of a nice data set because you have it organized or whatever else there. I just don't know how that data then flows to things like Westlaw or stuff like that, because it eventually has to get there or something like that, or in some type of database. Surely there's a standard for it. I just don't know about it.
Interesting. My guess is that it's inside the PyDoc currently, but so basically it's like for each case, kind of like basically a summary on like what happened, so that you can prioritize which case should be like done first, basically.
I don't know the data. I don't know how these data sets are organized, but like I at least know like Nexus, Lexus, and Westlaw have giant amounts of this legal research. I just don't know how they get it, I guess. So
Okay.
if that guy knows how this case management system works and how that data flow is originated, that might be an interesting way to solve that problem or start to solve that problem for programmers.
Okay, yeah, that's a great point, but yeah, I haven't looked into that currently. But yeah, it does sound interesting, kind of assigning priority for each case in a way. Okay. Okay. Legal researchers publish directly on website. Oh, I see. That makes sense. Okay, yeah, it's 2 p.m. now, so I guess I will first like advertise the next presentation, and it'll be by Eric, and it'll be on the topic of something called Mamba, and oh, I guess it's not famous enough yet. But yeah, kind of like this is like an architecture that's popping off recently, but basically the idea is like currently for transformers, the more we increase the context length, the compute cost kind of grows exponentially. So like when we want to evaluate 2,000 tokens, it can be like 4 times more expensive than 1,000 tokens. This and also a paper called RWKB is a paper on like linear scaling of that. So basically 2,000, a sequence length of 2,000 will cost the same amount as a sequence length of 2 times the sequence length of 1,000. So yeah, it's a kind of like a very promising research on something that might replace transformers in the future. So yeah, I hope you guys, yeah, I'm personally am very much looking forward to it. So yeah, shout out to Eric, and for like a link to kind of like choose the meetup time, you can kind of put your availability in here. And currently, I think it'll be, I guess, around like 4:30 p.m. EST. So yeah, that'll be for next week. So yeah, any other final questions? It's like on the page. Yeah. Honestly, arguably, I think the data issue might be the largest issue because, like, for example, for the contradiction stuff, I felt like if you have all the arguments and stuff, you can kind of like come up with like seeing how much contradiction is actually done per each case, and basically have like a heuristic on like, well, yeah, like which you can have like a heuristic on like which arguments will most likely not be contradicted in a way. And case info, yeah. Data published publicly. Yeah, kind of like one thing I found interesting when checking out the papers for this is like a lot of them are like behind a paywall, so I wasn't able to like, I need to access through my university, which was a bit annoying. Yeah. But overall, yeah. Any final questions? If not, I think I might just head to my class. This is from quotes to extent things with. Yeah, this is true, but yeah, as he said, it costs money, and I don't think that's scalable in a way. Like, we want to scrape everything for free if possible, or like use an API like from the code listener. Okay. I guess, yeah, that's about it. Yeah, any final questions? Actually, let me see if I'm decoding properly. Okay, I am decoding. Okay, well, thanks for everyone for coming to my presentation, and yeah, big shout out to Sing for like helping me in this presentation. And yeah. Oh yeah, and finally, if you want to read like more details on like the math behind the argument frameworks and stuff, you can check out this write up here, where I kind of mentioned some stuff that I didn't mention in the presentation. So feel free to check it out. But yeah, overall that's about it. Thanks for coming, and hope you all have a nice day.
Thanks, man.